Here it is. Okay. Great. Okay. I just kept losing this window. All right. Okay. I'm glad to see you all. Yeah. Thank you for asking that question. We'll just consider this temporary. Okay. Online. I think it kind of works because many people are emailing me saying they're COVID positive. And in fact, Panini, my son also told me he's just tested COVID positive. So I got to be careful. In general, I don't want to spread it. Yeah. Okay. So, all right. So we'll do this. But I want to meet on campus before week 12. It was fun, wasn't it? I mean, when we coded in class together, it was fun, wasn't it? Raise your hand. Yeah. I don't know. Yeah, I think it was fun. Yeah. So ideally, I'd like to get back to class. Maybe week 10 at least. Week 8, 9, maybe 9. It'll be safer. But week 10, we'll aim for that. Thank you for asking. All right. So Vivian, where's Vivian? All right, there you are, Vivian. Okay. Thank you for, thank you for asking the important question and also saying, pointing out, the emperor is naked. Okay. So we can move forward. If you guys are, if any of you are struggling, okay, any of you are struggling, we got to step back and find out what's going on so that we can address this. Okay, let me increase the brightness a bit. Hey, Chris, where are you? You got this glass building. Oh, is this the STEM? Is this the PSEC building? You're right in front of the PSEC.
No, I'm in Mountain View Library.
Oh, you are. I see. Okay, all right. Great. Wow, and it is bright out. Oh, it's indoors. I see. Okay, I thought it. All right, great. So here's what we'll do. Today's class. Let's take. By the way, everybody else should also switch on your cameras, okay? And people are still joining, so we'll give people a bit of time to get on Zoom. And Liam, okay, that's okay. Yeah, but Liam, try to participate vocally whenever you can, so that we all know that you're also here. Okay, so one of the important things about this class is helping each other, and that should happen a lot more than what I'm seeing right now. And I understand that right now maybe you guys are busy with lots and lots of week 6 and week 7 work in other classes, but you got to set time apart for this. Yeah, because like I said before, I think this is something that I will not compromise on. And even at Foothill says, why you got to do this because the students are complaining. I think I will basically just say, no, these are the basic standards in my class. Nobody gets secret help, one-on-one help, because everybody is entitled to that knowledge. And and the other thing is that everybody will be measured to the same standard. Just because you've got unexpected challenges at that time in your life, it happens to everybody. You can't say, well, I got challenges, so give me a freebie A+. Or give me a pass on assignment number 6 or 7. It's happened a lot. It happens in other classes I know, where students come and ask, saying, hey, I got really tough time with this lab, and I need something to happen, and they'll say, all right, 20 points for that, right? And that nobody learns from this, so that I don't think will happen in this class. Right, so I'll make it very clear in the syllabus so that people don't make assumptions and then go complaining. Because if you complain, then what happens is that there will be students in class who actually expect a certain way of learning. And then if the standard is tossed out the window and say, okay, anybody gets an A+, it's no fun for them. Yeah. So no secret answers to anyone. Yeah. I don't think you guys are, doing anything bad. In fact, all of you are attending class, which is fantastic, right? There are people that you got to get the message out. I told my 2B students to got to get the message out and make sure that everybody attends these sessions. These are it's super important, especially because I'm getting these videos, downloading the videos and posting them on YouTube. And at the end of the day, I don't even know if this is allowed by Foothill. I mean, it's FERPA regulations and all. So maybe I got to check and say, hey, you know what? These videos feature faces of students, and that's prohibited. Yeah. So maybe I'll just take, maybe I won't post these videos, and they'll just be for the audit, for the record. If someone says, hey, I was present, I can look at it. That means that more people have to attend class in order to see what the hell is going on. And for next quarter also, I'll just post a list of topics. And the idea is that everybody will, do some research on the topics, and then anything they're not clear about, they need to ask. And I'll set some time apart every week, whether it's online or face-to-face, some time apart where we can actually, people with questions can come and ask questions. It just be like a regular class, anytime, okay? Within reason. So I think that's how we'll do it. If you are going to go on and do 2B, any of you, I think, some of you are planning to do 2B with me, hopefully. Yes or no? Hey, actually, you know what? Enrollment begins next week. This week, 16th. This is 16th is this week? Yeah, okay. Enrollment begins on Thursday. And Stacy sent an email out. Did you all get the message? Yeah, I forwarded an announcement. 16th of this month, Thursday, is registration begins, early enrollment. And apparently there's a truck serving free burritos for breakfast and lunch for the students who go and say, I want to register and give me a burrito. Yeah, okay, cool. Right. So you can do that. But if you're planning to enroll in 2B, just go ahead and enroll as soon as possible. Okay, because actually raise your hand so I can get a rough head count of how many people are planning to go on to 2B next quarter. Yeah, so a few people. Yeah, Omkar, Krisha, yeah, hey Raj. Oh, yeah, all right, there's pretty yeah, Jonah, you too. All right, great. Yeah, I would like to see more of you, all of you, in fact, in 2B. 2B is a lot more fun. Okay, you may think that 2A is a bit of a grind sometimes. 2B, you'll be blocked, but like in 2A, but you won't be blocked in totally frustrating ways, like formatting errors and stuff like that. You got to get that right, obviously, right? You need to know what the customer wants so you can deliver exactly. I want pink shades. You can't do a fuchsia when someone says I want a pink car. Yeah. So so all of those, you got to account for the micro detail that will be taken care of in 2A. In 2B, so you won't have those frustrating blocks where you can't see what's going on. Well, you can't see what's going on because it'll all be in a logical space, but it'll be a different kind of fun challenges. So it'll be fantastic. Okay. All right. Click if you want to switch to a different microphone or speaker. That's not to me. Oh yeah, Krishav just raised his hand. Thank you, Krishav. Okay. Yeah, Simon, also you should switch on your cameras. Just here in Omkar. All right. Okay. So here's what we'll do. I don't want to go on to cover pointers. I know Isidore said let's go on and talk about pointers. All right. So we don't have to do it. We have time. Okay. We can defer talking about pointers until week 10. Okay. Week 10, ideally, I won't push it past beyond week 10. So this is week 8, and then there's week 9. Week 9 is a short week, by the way, because no class on Thursday. It's Thanksgiving Day. Yeah. So there was a dinner here and all. I don't know if but COVID risk and all, right? So but you want to be careful during that time, because after that is you got to prepare hard for the final. So what we'll do is next week we only have one class. That's week 9. So we'll cover all of the material, including functions and methods and parameters and everything until now, including arrays of objects, all of that. Yeah, arrays of objects. I'm not going to do, unless you guys want me to, I'm not going to talk to you about searching techniques. Okay, searching meaning linear search and binary search. If you're okay with that, raise your hand. Okay. Let me see. Hey, yeah, okay, it works. Yeah, thank you, Juliana. All right, so and this should be a single thumb. I'm getting better at this. And this is the balloons, or something was balloons. I need to hold it there for the AI to pick up, like it's still. All right. So anyway, so what we'll do is all the way up to not for you, Zachary, not happening. You got to have both hands up like this. Yeah, see, there you go. Hey, both hands, and it'll work. Try it. Other guys should try it. Okay, not just me. And also I'll ask a good question right before that, so everybody gets it. Was this a good class? Everybody thumbs up. But here we will cover all of the material until methods and arrays of objects. Okay, that's what we're going to do now. Anybody has any question on any topic we've covered from day one, okay, ask. And what we'll do is essentially just do another class. It'll be like a condensed class, because it won't be like drawn out with lots and lots of fluff and filler material. Okay, be a condensed class. Let's say you say I don't understand how input output works. Okay, and say, all right, let's take a practice cut at it. And you take the screen. I'll say, write a program that's going to ask the user for their name and going to say, hello, Jonah, or something like that. Yeah, that's all. So you got to, and say, let's say you say, I don't know how to make a class. with objects, a class and objects out of it. We'll do a very simple class. We'll do a very simple class and say, I'll say, we'll take the screen and I'll say, make a class of called student, right? It's very simple, right? Student, you know what? Let's make a class called a course, okay? Which personalized for you. But course, it'll have a string for the name of the course, and then maybe a letter for the grade, or a string for the grade, because A plus and A minus and all 2 letters, right? So that's it. Very simple things like that. And then we'll say, all right, now we make it private and public, and these are methods, add methods to it. All of those things, we'll get a chance to exercise all of those skills, right? And again, like, I want to reiterate this. It does not matter if you know this stuff, okay? What matters is that you get lots of practice, because you can know, because you can read it. And, tell me, many of you are math students, yes? All right, so think about it. So before the final exam, if you just go through the math book, because I'm telling you this because it's happened to me so many times when I was a student like you, right? Before the exam, I read through the book and I say, oh yeah, this proof, I can follow this proof. All right, okay, all right, I derive it. Okay, great. Okay, I understand every single thing in the math book. I go to the exam and I get a question that is exactly the same as something that I skimmed through before, and I get stuck. Why? Has this happened to you, by the way? Right? Because you understand a math proof or understand something logical, and you say, okay, now I can do this too. And I think it's the same thing with music too. But a music expert has to confirm that. In any field, really, you look at it and say, okay, looks simple. Actually, I think it is very true in art, because if I went to Andy, I was a student with Andy Rubel. Faculty can also enroll in classes, so I enrolled in Andy Rubel's ceramics class. And because I went to see him throw pots at one time. It was so simple and cool and easy, and I say, yeah, even I can do that, okay? And then I enrolled, and that's when I knew, right? Practice it matters so much, because I was there the whole quarter and I couldn't get anything half as perfect as Andy had it, right? And I knew that I know how many more hours I need to get to somewhere near what he's producing. So like that, okay? It's not just you can't say it is physics or computer science. I can just understand it and move forward because I got an intellectual, highly capable brain. Doesn't work like that. Okay, even if you have a highly capable brain, you're a genius. All right, that means you're capable of doing things. But if you don't exercise those muscles in your brain and say, well, I'm going to keep trying this again and again, you're not going to get positive reinforcement for those neurons to build or whatever it is, right? I'm talking from a neural net point of view, from an ANN point of view, artificial neuron, right? So you got to keep doing that, just like physical muscles. You got to keep doing that, repeated practice, and that will basically set you up to say, all right, now I got a new problem I've never faced before, right? Or even the same problem, but when I get stuck at this point, I'm not stuck for solutions, thinking, oh, how do I solve this? Because now it's if I only knew one way to do it, I might get stuck and say, oh my gosh, I forgot how to do it, right? But the virtue of practice is that you will not know one way of solving things, because by doing things repeatedly, you would have faced different solutions to the same problem as appropriate to different situations. Therefore, when you encounter a situation, you'd say, well, you know what, there's an arsenal of techniques I can draw upon to solve this problem. So that is the benefit of practice. And so you got to all practice, okay? I have to be in class and practice, and I'll see how I can change the structure of this class, maybe next quarter, right? Next quarter, and make sure that everybody comes to class, maybe weekly exams for classes, students, and say, you got to be conversant with all of the topics this week, because the last couple of days of the week will be exams, personal exams with me, one-on-one exams or two-on-one exams like that. So I think that anything that will help you guys, okay? That's what we want to do, okay? Also, vectors and lists, no, we didn't do lists, linked lists, okay? Vectors, you got to do vectors. Yeah, so let's, if you guys are, by the way, arrays and vectors, they are important to know. Again, I don't want to, never ever underestimate it, I think, because I used to do that. You see, people say, all right, I know vectors and arrays are introduced in week 5 or 6, but linked lists come in week 9, right? Therefore, linked lists are a more advanced data structure that can do more things. Actually, that is a complete, in my experience, in my personal experience as a programmer, manager, software person, I know that is the worst thing that a programmer can believe, because an array can do pretty much anything a linked list can do far better. And the reason I say that, based on my hunch, right? And, I think you can do a measurement and find out also if you want, because linked lists are on the heap most of the time. And they're not in contiguous memory cells, right? Even if the array, like a vector. Now, if anything I'm saying doesn't make sense to you, you just have to raise your hand and say, all right, no, I don't understand this, okay? We can dive into detail because it's important, okay? Because an array is made up of contiguous memory cells of same, the same width, yes? So even if it's in heap, you don't have to dereference and say, all right, no, I've done this element. The next one is not here, but actually there is a pointer here that says where I need to go to find the next one. That's what a linked list is. Okay, and they're both linear in time. These are terms you'll come across towards the end of this class, week 12, and also the beginning of CS2B. This is super duper exciting after that, okay? Once you get to know how to measure these things. In fact, today we'll do this, right? We'll do a project today, which is, very simple. Someone who's uncomfortable with vectors, they need to do this, okay? So we'll fill up a vector with 1 million items, okay? Fill up a vector with 1 million items, and then what we'll do is, fill up a vector, but it has to be in reverse order, right? Meaning that the first item is the last one to come. So you're going to get 1 million items, but the last item is the first one you'll get. So, it is like a stack, but how would you do that in a vector, all right? Maybe it's not 1 million items, so you can't pre-allocate and all, okay? So we will try an approach where we'll actually always use push front, meaning the first, we get the element, put it in a vector, the next one goes before that. So this one has to move down, okay? So now you can imagine in your head that's a very inefficient way to do this, yes? Because, each time you insert something, you got to move a lot of elements down the vector. Yeah, so if you have 1 million minus 1 items, right, in the vector, and the millionth item comes along, you need to move all of these guys down, 1 million minus 1 items, one level, right? So if you sum it all up, what you will see is that, the amount of moves you have to make for the very first element is 0. The number of moves you have to make for the second element is how much? 1. Yeah, because the first element is there, the second one comes in, and the first one needs to be moved down and the second put in place. Yes or no? Omkar typed yes. Hey, Omkar, is your microphone working? You should also, speak up, okay? Roger, welcome to class, okay? I didn't see you last time. And hey, Milton and other people should also switch on your cameras if you're able to, yeah? Okay, all right. So, what was the question? Yeah, a vector. I was talking about vectors and pushing elements down. Yeah, right. So the first element does not need to be moved at all. The vector is empty. Put the first element in vector space 0. The second one comes along. This guy, the one in space 0, has to move to space 1 because the new one now goes to space 1, space 0. Yes or no? Because if you're okay with that, give me a signal, in some way. Otherwise, I don't know if I'm right. Okay, a couple of people, but not everybody. I want everybody to be unanimous here and say, are you all on the same page that every element that comes along will have to move a certain number of elements? The first element, no move is required. The second element will have to move the first element. The third element will have to move 1 and 2 elements. Yeah. I say, how about I do an experiment where I don't actually say anything until I, all right, Kira was kind enough to, all right. So, but most of you are not, I don't know if you can hear me even, right? Rebecca, is it your thumbs up or are you just thumbs up? Okay, thumbs up. How many, so which means that some people are still not clear on this, okay? Thank you, Zach, okay? If some people are not clear, we're not moving forward. I need everybody to clear on this, right? Because after this, what we'll do is we'll do an experiment, okay? Because we'll start with vectors. Unless someone wants to do who is unsure about input and output and expressions? Raise your hand if you want to do a very short program that involves input and output, C out, C in, right? And expressions, calculating something, right? So you say, what is your age? Or you could say, what is your day of birth? Okay, and then you can say, perform some arithmetic and come up with some number and say, this is your magic number. Something like that, okay? But it'll be an expression to calculate. You want to do that? We've done that already in the first few quests. But if you want to do that, we can do it. Otherwise, what we'll do is that, what did we cover after that? After expressions, we went to arrays. Yeah, vectors and arrays. So we can just go to vectors and arrays. These are, like I was saying, most powerful data structures. Even, linked list, I would say never even use a linked list. We only use linked list for pedagogical purposes, meaning, here's how a pointer would work, right? And because otherwise, linked lists are practically useless, because just the cost of going from heap, one location to another, this dereferencing and going through a pointer is a hell for, hell of a job for the CPU. Instead of saying, I'm just going to increment by one and get the next item. So that means even if you move a lot of items contiguously, that's not a huge cost. But if you actually traverse contiguous locations, that's a huge cost for the CPU. You will actually experience all of this, right? When you complete quest number 9, you'll know how linked lists work, and then you'll implement the destructor and all, and you'll see, right? Oh, wow, that is why it's so costly, right? And so you'll learn to avoid these things, hopefully, right? Because I know non-C++ and non-C programmers, they don't have any reservations against using linked lists or maps or hash tables willy-nilly. You just throw it in and say, hey, I'm going to use an array list, I'm going to use this, right? But you always have to look at the situation and the data structure that it dictates, and you'll get that by practice. Is that okay? So we're going to spend a lot of time with vectors, lists, week 12. Okay, well, we'll do linked structures in week 11 and week 10 and 11, and we'll cover that then. We have a lot of time. So who wants to do what?
Is a linked list equivalent to like a Python dictionary?
No, a Python dictionary is what is called a hash map. JavaScript and Python, yeah. So yeah, a linked list is basically a linear data structure. Linear meaning each element says that's my next element, and you just hop like that. But you need the address where to go to from each guy. That's the linked list.
Okay.
And it's linear because to get to the nth element, you have to do n hops. Yeah.
Yeah.
And I said it's not a good idea to use a linked list because those hops are very expensive. Just dereferencing. Because imagine, right? If you're playing treasure hunt and each piece says, you got to go from here to San Francisco, Twin Peaks and get the next clue. And then the next one sends you to San Jose, right? That's a really big pain, as opposed to going to one place and saying it's a grocery store. All of them are in the next, marked aisles, one after another. So that's the power of the array. So we'll continue to use vectors as much as possible, and you can use that as a hint from me, and you can check it on the internet, or you can do your own test and convince yourself. But you can convince yourself that vectors are one of the most powerful structures. Okay, so even in other languages, try to use vectors as much as possible. And also in JavaScript and other languages, you got to be careful that you're actually using a vector, because if you use an array, I don't know if there are any JavaScript programmers. If you use an array with a number index, but the number is within quotes, because I've seen lots of programmers do that. If a number is within quotes, it's basically a string. So it's actually a dictionary after that. So if you can't have a number within quotes as the key should be, so that is a hash map, and that's a dictionary. And a hash map, well, it's also constant time. Again, it's not always suitable. Okay, there are certain situations where we can use it. We'll come across all of the situations in 2B and 2C. Well, in 2C, right? 2C is when we'll do hash maps. Different ways of structuring hash maps, different ways of resolving collisions. When two people compete for the same spot, how do you say this one goes in the hash and the other one is, and all those interesting things that we can look at later on. Okay, so how about today? What we'll do is how about this, right? And this is going to be a useful experience for you too. And who is uncomfortable working with vectors? And this is what we're going to do. We'll just create a vector. Someone will walk you through it, or I'll walk you through it. I'm going to create a vector of, let's start with 100,000, okay? Let's start with 100,000 random integers. And you're going to get these numbers in reverse order, okay? Reverse order. So you're going to push them all in using push front, okay? Push front, meaning the element always goes in the front. And you are going to calculate the time taken, right? The time taken. How do you calculate the time? So that is what I mean. It's a useful skill to have. So you're going to calculate the clock value. There's a system call, not system call. You can make a function call. We'll find out, right? We'll Google and find out. It'll tell you what the current reading of the clock is, and then do all of your vector insertions, and then do a clock reading again. And say, hey, now it's 29 minutes, and that was 27 minutes, so 2 minutes, right, is what the loop took. That's all, okay? And then you'll know, well, for this many elements, I'm taking 2 minutes, right? Let me change the number of elements. And you can actually be plotted in Desmos or something like that, or in Google not Google Maps, Google Sheets. It'll be fun, okay? So I think we have a decent menu of options to try today. That's vectors. And after vectors, we'll if someone wants to play around with stacks, no, not stacks, classes, we still have Thursday's class and also the class next week. Classes, objects, and methods. Okay, so we can take our time, and in between too, right? If you guys want extra classes, I'm happy to consider having a class. Even weekends are fine. You know, for me, it doesn't matter which day it is. Most of the time I don't know if it's a weekend or not, because I'm pretty much, you know, doing interesting stuff most of the time. You know, I'm looking at what you're writing, your code, and it is fun for me. Okay, so most of the time.
Can I ask what a stack is?
A stack is a data structure. It is like an array, except that it's an array that has a special constraint. You can only access one end of it, the other end you can't. Right? So now you'll know why it's called a stack. Because if you can only access the top and not the bottom, you know, it doesn't have to be one end, right? We'll assume it's a top. That means you put stuff on it, but it's all a stack. You can't access anything underneath unless the top ones are gone. So the last thing to go on is the first thing to come out. That's a LIFO data structure, LIFO. That's what a stack is. You can have a stack of plates, you can have a stack of numbers, you can have a stack of strings. In fact, in quest number 8, you will be implementing two kinds of stack, right? You'll be implementing an integer stack in quest number 8. Yeah, it is actually, you know, that is one of the simpler quests, right? It is actually easier than quest number 7, which is binary search. Lots of students get binary search wrong, and because of corner cases. But you know, stack is super duper easy. But and again, let me give you fair warning that, you know, quest 9 takes more time because it's linked lists and it's pointers, and you're probably dealing with pointers and indirection for the first time. So make sure that you don't finish off the stack quest really quickly and then say, well, you know what, I did it in 1 day instead of 7, so I'm going to slack off the next 6 days. No, that means you add the 6 days to the next 7, because the linked list quest could actually take you 13 days. Yeah, because yeah, maybe I should think about reordering these things so that people don't get misled. Okay, all right, so how about this? Who wants to create an array or a vector? Now, this should not be someone who already knows about these things, okay? Someone who's not comfortable with vectors and arrays. Actually, you know, Vivian or Juliana, someone said, you know, we'd like to look at some of the earlier concepts before we move on, right? So pick an earlier concept. May not be vector. Pick an earlier concept and say what it is that you want to rehearse, right? Rehearse essentially, and we'll do it. What would you like to work on, right? Anybody, yeah? And we'll do it with everybody's agreement, okay? So you can't say, oh, I want to do, you know, stacks, for example. Liam could say, well, I'm interested in stacks. Liam, yeah. Liam, you were the one who asked about stacks, right?
Yeah, I'd like to do that,
Yeah.
but I think it would not make sense. Maybe do arrays.
Yeah. That's what I was about to say. You know, because he asked a question about stacks, he could say, well, I'm really curious about stacks, so let's do something about stacks. No, all right. So we'll wait. Stacks will get its airtime later, but for now, it has to be something up to week 7. Okay, up to week 7. Anything that we've talked about until week 7. Hopefully, it is not about data conversion. Okay, so we don't that much should be internalized by now. Yeah. So anything past data conversion to functions, right? If not, one of you should take the screen and we will work on vectors, okay? Because I think that is the first point where people could get stuck. You know, how to manipulate a vector, yeah? And looping around vectors, all of those things are useful skills to have. So that's where we'll go. So who wants? Why is it? Why is nobody talking? Okay, why is nobody talking? And well, actually, Vivian, you said you wanted to talk about some earlier topics before we move on. Yes. All right. So pick an earlier topic. Pick an earlier topic, and then we'll say, all right, let's practice that.
Practice enums.
So I'm sorry, Vivian.
Like enums.
Enums. Well, are enums in the yeah, we can absolutely do enums, right? However, yeah, we'll do enums. Okay. All right. I want to build enums into one more. Okay, not just enums, because enums is we'll use enums in whatever we're going to do. How about that? Yeah. So whatever we're going to do today, we'll use enums, and then you'll get an idea. There's not enough to talk about in enums for a long time. So we'll. All right. How about one more thing? Okay, enums. We got one item. How about one more thing?
arrays.
Arrays, yeah, arrays. Okay, great, Liam. Great. Okay, so we've got right, so Liam, are you able to share your screen, by the way?
I'm actually on my laptop, but I could switch to my desktop.
Oh, I see. Well, you got to log out and log in and all.
Yeah.
I see. If you can do that, that would be great because you'll get practice. We will actually code a problem with vectors and use enums in the process. Yeah, we can do that. If you want to set up for the the next opportunity, which may be in 15 or 20 minutes, someone else can take the screen now too.
Sure.
You want to do it now, or you want to log out and log in into your desktop, or do you want someone else to take the screen now?
I guess I could go second.
All right, so Liam is going second. How about someone else who is unsure about vectors and arrays? Okay, we'll use vectors, not arrays. I'll show you what a native array is, but we'll still use a vector because it's a lot more convenient. And I'll explain the difference between them again, if necessary. But a vector is for all practical purposes the same as an array, except it lives in a heap, not on the stack. Right? That's yeah, irrelevant detail for most of the processing. Who's unsure about vectors? Yeah, Raj, you want to take it? Great,
Yeah, I can
great.
go.
Thank you, Raj. Okay. By the way, Raj is the only one who volunteered. There's so many people in class. All of you should be thinking about grabbing this chance to volunteer and code. Yeah. Especially since I'm thinking I won't even share these videos on YouTube from going forward. That will encourage you guys to actually come to class and take the screen and practice, because you can't say it's going to be recorded, I'll watch the code, someone else code later on, and that won't be possible. Okay, so here's what we'll do. All right, so in fact we will have let's start with comments at the top. Delete everything, Command A and delete. Yeah, Command A, delete. All right, so start the comments at the top and say practicing coding for practicing coding. What is today's date? November 14, right? Tuesday. Yeah, no, yeah, 11/14. All right. So all right. So next and on the next line, you can say this program will fill a vector with random integers. Fill a vector with random integers where the integers arrive in reverse order. The integers arrive in reverse order to the final ordering required in the vector. Okay, this is a very simple problem, isn't it? It's a very simple problem. In fact, if you're going to be, right, I was going to say, if you're interviewing someone, this is a good icebreaker to ask them. Because and you'll find out why it's a good icebreaker. And also by doing this, you'll also get a very good feel for someone to ask you a question like that in an interview, a software interview. You can say, well, all right, here's how some people will solve it. Here's how a software engineer will solve it. And you'll know the software engineering way of doing it. Yeah. Okay. So we're going to do that today. I think it'll be exciting. So if everybody's on board with this, this is what we're going to do. All right. Oh, we want to work in enums. Enums are what are called enumerated types. Okay. Enumerated types are, so suppose you have a program here. Yeah. All right. Suppose we have so I'm going to explain this, and you all got to chime in and say yes or no after I explain what an enum is, right? Because then we can move on. And when you write a program, sometimes you may have some fixed states, like, I have to write to a file. Okay, I have to write to a file. And maybe the file can be in multiple states that are known to the operating system, right? Or so maybe the file doesn't have permissions for you to write. Maybe the file doesn't exist. Let's pick one more. Maybe the file exist. All right, but maybe the file is write protected. It's the same as not having permissions, but we'll just say, for argument's sake, the three possible values that when you read the file, you could get, right? Now, your program, maybe you create a function. We've all talked about functions, right? Suppose you create a function that is going to open the file, and it is going to return an indicator back to the person who says, go and open the file. Right? And you say, all right, I open the file, here's my status. But the status is not success or fail. Now it has multiple statuses. Now we had this exact same question before in a slightly different context. So I hope you recognize this, right? So yeah, I think it was when Panini was coding something and he had to return he tried to return two values and then return a pair or a struct or something like that. We shouldn't do that. I told him to. The right way to do it in C++, non-C++ programmers do it that way. That's why I was, very curious. In C++, you pass multiple values back through what is called a reference parameter, right? And in case any of you are unclear about what the reference parameter is, remember, after this, or maybe next class, we will do more exercises using reference parameters and things like that, okay? So that's another thing you got to be super solid on. All right, so anyway, suppose your function can return 0, 1, 2, 3, or 4. All right. Now, imagine in your mind what a pain it would be for someone calling your function and the function returned value 0, 1, 2, 3, right? And they didn't know what the codes were, right? In your calling program, the guy called this function and gave me number 2. What does 2 mean? But you know, as a designer, that 2 actually means file not found. Yes or no? Right. As the person who wrote that function, you know that if the file that you're trying to open is not there, you're going to return number 2 or status 2. If the file was opened successfully, maybe you return 0. No errors. Okay. So, but now the point I'm trying to make is that I'd like all of you to appreciate what a pain it is for the person who's calling that function to decipher its return value. Yes or no? If it's going to return a number, like a naked number like that, 0, 1, 2, 3, 4. Isn't that a pain? 200, you got to look in the documentation and say, hey, what is 2, right? That function returned 2. What does 2 mean? Yes? Okay. All right. So there should be an easier way to tag these things. And one of the ways is what is called an enum, right? An enumerated type. What that enumerated type, it's an enumerated type is a fancy word. And that's why, people just say enum, right? Enumerated type enum. And enum is basically a collection of strings that stand for values, and you declare that by, we're going to do a sample enum here. We'll just create a sample enum, and then we'll tie it into the project, right? So say enum, enum. I actually have, I haven't used enums in such a long time that I've probably forgotten the syntax, but we'll look it up if anything is wacky here, right? Enum, and then just like a class, right? You're just going to say class is open. Yeah, open. No, not class. The thing for class, the curly brace. Yeah, enter. Right now, and on the first line, you say all uppercase. No, all uppercase say success. All uppercase success. Right, and then comma. On the next line. This, you can do it on the same line, but next line is conventionally, lots of people do that, right? And then you can say file not found with underscores between the words. File not found. Yeah, all uppercase. Everything is uppercase. They're all constants. All right, a comma. On the next line, you're going to say no permissions. All right, three values. That's enough. Right, no comma after that, and close the brace, and then semicolon after that. Now we need to put a name for this enum. I think the name goes there. Thank you. Who is typing, by the way? Raj? So you probably know.
No, I don't.
So someone could also confirm this on Google. You know this, Raj?
No, absolutely. No, I don't.
Yeah, well, I think your intuition is probably correct. That's where I would have put it too. But someone could, Ben, or someone could Google and say, where does a tag for the enum go? I'm pretty sure it goes there, where Raj has the cursor, and say status, right? Status. Just call it status for now. Status. No, uppercase status. Or no, uppercase S and then status, just like a class.
All right.
Status, right? Now in your program, what you can do is you can include this enum. If you have this enum, you can basically say in your return value, if the file was not found, return status.file not found. Okay. Now internally, the compiler takes care of this thing, right? The compiler takes care of saying, well, what enum means is that person just needs 3 distinct values, so that when file not found is returned and this person checks for file not found, they don't need to know the 2 is file not found, right? So they're going to return file not found as a value, And so in fact, what you need is a variable, just like a class. Remember, that's why it is just like a class. It is a type, like an integer, character, anything else. This is called an enumerated type. It is just a baby class. Think about this as a baby class, okay? Before you learn about full-fledged classes, which allows methods and things like that. It's a baby class, which can only take these three types. So this, I mean, these three values. Like a character can, thinking, no, all of these things can take multiple values, right? Okay, so you're defining a variable. No. Let's do main. Let's do a main. Let's line 11. Just do a main. Let's do a main. Yeah, int main. Yeah. And parameters for main, right? Yeah, arg c and arg v. Yeah. Oh, actually, we don't need any parameters, but no, just no, we don't need. Yeah, just the braces. All right. So in here, what we can say is status space. No, it's status space. St. Just call it st. Enter. All right. Now, what you can do is on the next line. You can say st. St equals, I think this is the way it goes, okay? Status with a capital S, dot file not found, right? All right, semicolon, and then let's do a cout of st, right? Cout, st equals within quotes. Can someone please Google and find out if this is the right syntax? Hey, Chris or Chris, maybe, you're the tutor. Can you Google and find out the right syntax for enums? Equals, and then the value of st, and then enter after that. Now, when you print the value of st, you're going to be surprised, okay? Endl after that. No, I think you need st inside before the equal sign. Put st. No, before the equal sign. No, you need endl after that. That was all good.
Yeah, I was just
before the equal sign. No, wait a sec. On line 14, go just to the equal sign. Go to the equal sign. Right, left space. Well, left. One more. Right. Type st equals.
Oh, I
st.
see.
It looks like there
You want to
shouldn't
tag
be.
it essentially. Yeah, that's what I meant. Yeah. And then you want st. That should be within quotes. St equals should be within quotes.
Professor.
No. Right? Yeah, put the quotes there. Put a double quote there. Right. Is the online GDB is messing with you, right? Because when you put a quote, it's inserting more quotes and all.
No, I think I'm just typing it wrong.
All right. So here's what you should do. Just keep typing backspace. More. Right. Stop. No, I think you went one too much. Put the quote back. All right. Here, you're going to type st space. That's it. Okay. And at the end, before
I see what you're saying. Okay.
Yeah. All right. Yeah. All right. Okay. Yes. Basically, we do this in all of the, I think, all of the programs, just to make sure that we got the right thing. So now, if you run this, no, before you run it, what do you think is going to print? Oh, I see. What is it? Oh, no semicolon there. You got a semicolon after no permissions. All right, run it. We got to figure out the right syntax for enum, right? Unless one of you has got.
I think on one of the quests, instead of status dot the value, I just used the value and it worked.
Oh, I see. Because the compiler knows that st is of status type. It basically just says, all right, okay. So what Spencer just said, that is the right way to use it. Okay. So when you use st equals file not found, it knows that st can only take on three values, and those three values are between the curly braces for the status type. Yes.
Mm-hmm.
That is what the enum means. Enum means any variable of type status can only take three possible values, and those are the three values.
I see.
Now, I think that is the easiest way to remember what an enum does. But let's make sure to run it and make sure that it works. Spencer, it works for Spencer.
You forgot to include all the things you need to include as well.
Oh.
So it won't run.
Oh, yeah. I'm sorry. Yeah.
That's probably what it
Thank you.
is.
Who said that? Yeah, Jonah. Thank you. Yeah.
Are there any
and you
other
use-
header files that we need?
we'll need vector for later on, but you can put, yeah, vector. And then endl and using namespace also, because you'll have a main in here. Yeah, you do have a main. Yeah. And then compile and run it. Yeah. And then we'll see. Oh, it's not status not filed out. Yeah, he says just get rid of the word status and then, yeah, that one. Yeah. All right. So now here's the funny thing. Now, and maybe this is a question in the final. It didn't print file not found. We assigned file not found, but it printed 1. Yes. Why did it do that? But I don't expect you to know the answer to this. Basically, the enums are basically just syntactic sugar for us, saying, well, you know what, you're going to be returning numbers, but I'll put these names on top of those numbers, and the compiler will take care of translating both ends for you. That's all. Okay. And it makes sure that, you know, anything of that type can only take those 3 numbers. It can take 0, 1, or 2, right? Success is 0 because it assigns them in sequential order. The first one is 0, 1, and 2. Now there are, you know, some details, right? Maybe even painful details about enums that are usually not used by many programmers, but it's in people talk about this in maybe in the exams and all, right? You could say, well, you know what, I don't want the number 0 for success and 1 for file not found and 2 for no permissions, because that's what you'll get. If you print all the values, that's what you'll get, 0, 1, and 2. Maybe you want different numbers. You know, you want 5, 10, and 15. If that is what you want, you can essentially define the enum in a different way and say status is an enum where success equals 5, comma, file not found equals 10, right? You can actually explicitly say these are the values they're going to take. They're like, if any of you know the language C, right? It is very similar to what is called a preprocessor directive in C, right? It is practically translated into that number for you. That's what's going on. Now, I didn't spend a lot of time in class about enums because that's all it is, right? That's all it is. And then there's no reason to freak out over enums and saying, oh, you know, it's a new thing that we haven't covered, because it'll be pretty straightforward and simple. When you, I think even in the text, it's probably 2 or 3 pages, right? I'm talking about enums, maybe not more than that. So hopefully that demystifies enums for you. What we'll do is we'll just go ahead with the vector example. I don't know if possible, we'll work the enum into the vector example. I said we'll do that, but we already covered enums. Hopefully that is clarified, the concept of enums for Vivian. Vivian, is the concept of enums better for you now?
Yeah, it is.
Was it you? Did you ask the question about enums, or someone else asked the question about enums?
I did.
You did, okay. So if anything here is unclear, all you have to do is just ask again in the sub, right? Chris or me or other people will jump in, and it's not directly about the question. So, you know, I don't have any hassles about you know, answering those questions for you. So you can ask these conceptual questions, but hopefully someone other than me will chime in and answer these, because by answering Vivian's question or someone else's question, if they have any questions about enums, you'll also solidify your own understanding. Okay, if that is all right, what we'll do now is go on to the main task, which is Raj is going to create in his main, he's going to create a vector. In fact, I'm not going to talk you through this, Raj. When you're stuck, right, go type. When you're stuck, someone else can call out the code, and nobody calls out the code, I'll call out the code. How about that? Is that okay? Is that a good strategy for practice? Because today really is practice, going over all the stuff we've done before, instead of, you know, so we've done everything once, we have time to go over this multiple times. So that's what we're going to do. So I'm not going to call out the code this time. This time you guys are going to call out the code. I'm going to be watching, but I'll help, you know, step in and help if and when you need me to. Yes, is that okay? So here's what Raj is going to do. Yeah, he's going to create a vector, and in that vector, he's going to do push front of 100,000 random integers. 100,000, right? 100,000 random integers, and we want to time it. Okay, we want to time it, and then we'll Google to find out how to time. I think it's clock, right? There is a function called clock, and you have to include some file, but we'll get to that, right? Once he's got the code that will fill it in, We'll run it and say, and after that, we will go ahead and time it. And timing is a useful skill. And again, in Shark, in 2C, many of your quests will also be timed and say, well, the reference code only took this many seconds. How many seconds did you take, right? And it's actually a great game. Lots of students actually love to just keep at it until they beat the reference code, and it's great. But timing is like super important when you're a professional, right? If you've got an algorithm or if you're reporting on a paper in a journal, you got to say, this is how the algorithm works, but I ran some tests and here are the graphs, times and all these things. People are looking for that. You can't say, well, I've derived mathematically that it's, O of n cubed plus 3n squared, right? No, all right, well, you derived it, but what's the proof is in the pudding. Run it, then we'll see. Because technically, although we haven't started talking about big O notation and things like that, you could actually have a constant time solution. A program that works in constant time, right? Another program that works in linear time, meaning that if you have n items, it'll take time that is proportional to n. So if you have a large number of items, it's going to take a large number of time, amount of time to process it. Whereas this one always takes a constant amount of time. But obviously, if you think about it just a little more, which most people don't seem to do that, right? Is that there is some period of time when this constant time algorithm is actually better than the linear, right? Even though linear is conceptually worse, it gets worse and worse, right? This is constant, always constant, but it'll be constant 1 million years. Whatever you tell me to do it, I'm going to do it in 1 million years, okay? It's never going to be better than most of the practical quadratic algorithms we have. Yeah, so you can even have exponential algorithms and they could work on reasonable data sets. So people always miss out, I think, or in non-professionals, right? Professionals, they know you got to measure it. The proof is in the pudding. I've been bitten by this so many times because many times when I was out there as a researcher, I used to say, well, this algorithm is kick-ass, right? It'll beat everything out of the water, right? And I go out, and in fact, I go out and in front of lots of people and say, all right, this is the algorithm and this is why it's faster. And but yet empirical tests make me surprised many times surprises. And you will also feel that too, right? And then after it doesn't work according to your prediction, you'll start looking at why the hell is it not working, right? What are the constant terms involved? Is it because of things? Well, we'll get into all that detail later on. Okay, so let's not waste time. So yeah, vector of int, and then you can say random ints, and then I'm not going to talk. Okay, so in fact, yeah, I shouldn't talk at all because that's why you weren't typing. I'll just watch. I'm just going to watch. You type, and people will tell you.
I mean, what should I call it?
Someone else, yeah, yeah. Why are you typing or
Yeah,
you're doing it yourself? Okay.
Yeah, I mean, I'm just waiting on some instruction, but
Yeah, and in fact, you should yeah, clean yeah, people should chime in. So the way you declare a vector, you can just put a semicolon after random ints, right? You don't need curly braces. Yeah, if you were not to do a vector, we're not going to do this, but you do this and then you can erase it. Suppose you wanted to do an array of a million integers, right? How would you do that?
I mean, you just
Yes,
have,
well, I'll talk you through the syntax and we can erase it. Right? We haven't used it a lot, so I don't expect you to be familiar. You say int,
then you
space
call
random
it.
ints.
Yeah.
Yeah, and then square bracket. And then you can say 1000 times 1000. Yeah, always, 1 million should be 1000 times 1000. Easier.
Oh, you want, okay.
Yeah, because that will be turned into a million by the compiler.
Why
Right,
is that
semicolon
better?
after that. Now, sorry, Liam, you had something?
Why is that better than just typing a million? Or even just
Because
1,000?
otherwise the programmer who's just reading through your code, zipping through your code, will have to pause for a millisecond to find out how many zeros there are.
Okay.
Yeah, because this one I can look at it and go on to the next line because I know it's a million. Yeah. This is just programming niceties that you leave for other people that will look at your code. That's all. You don't have to. All right. Okay, so that's how you do an integer array, a native array. For all practical purposes, a vector is better. It lives on the heap. That is the only disadvantage. It's not on the stack, it's on the heap. But and because it has to be allocated and deallocated, but the allocation and deallocation happen only once. When you say, well, it happens exponentially. Well, because the vector starts at 0, and then as you start stuffing in items into it, it'll just double in size each time. So that even if it has to allocate many times, it'll just be logarithmic in the number of elements because you're doubling each time. I don't know if that makes sense, but by the time you're doing question number 2 of 2B, you'll say, yeah, of course, that's what's going on, right? So, all right, so that's what a native array is, and we're not using a native array, right? So we'll just use a vector. And all right, go ahead. So what we need to do is you can use srand if you want, if you remember, but we don't need to. What we need to do is you need a loop which will stuff random integers using push front into the vector. And then after that, you can just say cout done, and we'll compile it and run it. And we'll see how long it takes.
So would it be better to use a for a while?
Someone else, okay, he's not asking me.
Probably a while.
And then does someone know how to fill in this vector?
So we add a random value to the end. I think you use like dot insert, like the name of it, dot insert, I think.
Or wouldn't you use pushback for a vector?
Push back or push front, I guess.
You can use pushback, but I don't want to. Who asked that question? Rebecca? Yeah, pushback is the right thing to do in most cases. However, we don't want to in this particular case because we want to know what is the cost of always pushing elements in the first in the front of the vector. Because once you know the bad thing about a vector, you already know from that point onwards. Because every time you know the disadvantages of a data structure, you know the data structure better. You know where not to use it. Most of the time, what I've found out there is that when people do half-ass things with data structures or things that are, work but not so efficiently, it's because they don't know where the data structures are weak. So they'll use it in places where it's not supposed to be used. And then the whole thing is kind of messy. And so that's why we want to run into these issues. This is the biggest drawback of vectors, okay? The biggest drawback, let's just face it right on and say, well, this is the reason why not to use a vector. For everything else, a vector is like super dandy. That is what we want to use. And I highly encourage you to use vectors, even if, it means that, I can use a vector instead of a tree. In fact, in quest number 8 of 2C, right? If you go on to do 2C, I don't know if I'm offering 2C because in spring, we only teach 2 classes. And I think both my classes are 2A in spring. At this present point in time. So I was planning to offer 2C in spring. That means, after that, I don't know if I retire, maybe I'll offer 2C the following year, one time. But if you do 2C in quest number 8 of 2C, you will actually be implementing a tree, okay? You will implement a tree, a binary tree without using pointers. Is that cool? How can you do a binary tree, a tree with no pointers? But you'll be doing that. And it is super cool because you can have all the benefits of a tree without having to, go from, Twin Peaks to San Jose by, you don't have to travel between the elements. In a tree, you have to. Every time you go to a node, that node will tell you, all right, these are my 2 children. One is in San Jose and the other one is in Baltimore. That could happen, right? And then you have a hell of a time, doing that. But if you can have a tree where all of the elements are in predictable places in a vector, that is the best of all worlds. That's why a vector is so useful and powerful that it is better to get to know its in and out, right? Ins and outs of vectors, the earliest possible time when you're trying to be a programmer. Because even interviews, when people say, here's a problem, try to solve it, try and solve it with the vector first, right? And then think about the other advanced use case data structures. Okay, all right, so push front, and you want to call rand, right? Yeah, I see. You can do srand there, by the way, right? Srand is for seeding the random number.
Oh, I see. Yeah. Do I need to put anything inside these parentheses, or is it just rand?
Don't you have to do the srand before that and then type null?
He said don't use srand just now.
You don't have to.
Create
Yeah,
it before you do it.
you can if you want, right? No, no, not there, not there. You should, that should be rand. I think who asked the question, by the way? Who asked the question about srand? Nobody?
I think he did.
Liam, you did?
No, I think Raj did. I just said you have to create the seed first.
Yeah, that's what I mean. So yeah, so srand, you can call srand outside of the while loop, right? You should not call srand inside of a loop anywhere. You should only be called once in main. That's all, right? Right there. If you want, you can call srand there, but that's not going to be relevant to our timing. Well, we can do it. We can do it, right? We can do it because, you know, different times, different sets of random numbers, different. Right. So inside you want to say inside the parentheses, inside the parentheses for srand, you want to say unsigned within parentheses of its own.
Oh yeah.
Yeah, unsigned. And then outside you can say a time t. Oh, your time null pointer. Yeah. Right. And then semicolon at the end, and then you can put a semicolon and then put a comment too, saying seeding the random number, because right now you had forgotten what srand did, right? So you're just seeding the number, seeding the random
What is
generator.
the point of
Yeah.
calling srand here for this program? I know that it sets a certain seed, but why do we need to do that here?
Yeah, so the reason we're doing, good question, Ben, okay? The reason we're doing that is because we're going to time how much time it takes to stuff a 1,000,000 element vector, right? Yeah. Now, let's say it says 4 seconds. Now, we're not really sure because we want to repeat the experiment many times and take the average. Yeah. In science, that's what we do, right? So one measurement is never enough. You got to take many times and then take the average, because the error will get canceled out. So the mean, you'll approach the mean of the actual experiment result. Yeah. Yes or no?
Yeah, I guess so. I guess so.
So if we want to repeat the experiment, we want to get a different set of random numbers each time.
Mhm.
Therefore, we'll just stick an srand in main, so that the next time he compiles and runs, it'll get a different set of random numbers, and maybe 4.1 seconds or 3.9 seconds. Because if you get the same set of random numbers, we can't tell much from that. Yeah.
Yeah, I see what you're saying. I see what you're saying.
Yeah. And in experiments, it is very important to do srand in scientific experiments, because suppose you're testing for something for ascending order or something like that. How much time does it take to take a bunch of numbers and sort them all up, right? And then maybe you have an algorithm that actually checks if they're already sorted and does nothing. And then, you call rand, and by chance you get all the numbers pre-sorted. So it'll say, hey, this algorithm took 0 seconds because it didn't do anything. But then you run it again, maybe you get a different sequence, then it'll do some real work. So you got to average many times. That's the reason. srand is like important. But right in this case, not so important, but we'll throw it in anyway. Put a blank line after that, and then, right? So now what we want to do is one more blank line, and then we'll say one more blank line. And we'll say, we want a comment. We want to time how long it'll take to push 1,000,000 integers into our vector. Is everybody okay with this so far? Right, we haven't done the timing yet, but we've put something there to say we want to time it. Yes or no? Yeah. Okay. On the next line, you're going to say on the next line, yeah, you're going to say, I think clock underscore t. No. There is a type called clock underscore t. Hey, can someone Google and find out what include file for clock, to use clock, and also if the syntax is, if the calling, the signature is right. Okay, clock t equals clock t space timestamp, say ts equals clock and open close. Now someone has to Google and find out, right? So do a Google of clock and find out if you got to include C time. Are you sure it's just C time for using clock? I'd be surprised if it was C time.
It's just in time.h, the time header file that we already included.
So line 7.
Yeah, well, why don't we just do a Google ourselves? Just go to another tab and say, go to another tab. Open a new tab, Yeah, and say C++ a clock function example. Yeah, right, so yeah, click that. All right, so further down, clock T. All right, clock T and clock. Oh, good. I still remember it. Okay, so clock is a function you're going to call. It's a library function, and it returns a variable of type clock T. Clock T, I think, is just a long number. Okay, it's a long number. So now it returns that. Now after, yeah, actually, there's a bit more in the documentation. And then what does it actually return, right? So we semicolon there, semicolon, right? And after the closing brace on 626. In fact, you can get rid of the brace, while, oh no, this is actually an error in the while loop. Okay, who's going to fix the error? Who's going to fix the, oh, actually, someone has to fix the while loop, okay? Someone has to fix the while loop. How about this? This is going to be practice free. I'm not going to talk you through this because when I talk you through this, then, you're making the same kinds of errors again and again, right? So I'm not going to talk through this, anyone through this now. You guys have got to fix it. What is the error in the while loop and how are you going to fix? Forget about the clock now, right? We'll come to the clock later. You got to fix that while loop, the loop, basically. You got to fix the loop. What is the error? Maybe it's an exam question. Okay, in the exam.
Do you need to declare size Ti or int or size T?
Yes. All right. So that is one of the things that is missing. So what Rebecca said is we don't have a variable called I. You can declare a variable inside the parentheses, by the way. Okay. So a variable has to be declared. Yeah, you can only have I. You can while I is less than 1 million, right? You just have to say while I is less than 1 million. So that means that outside somewhere you got to have declared I. Yeah.
Yep.
Yeah. And actually, yeah, all right. And then what is the other error? What is the other serious error? So, right, because in the exam you could have a question. This loop could be given to you and say, check all the serious errors in that loop, right? And one of them could be you can declare a variable where it's declared. And the other could be this other serious error, right? Or maybe you have to fill in the blanks and say what the error is. What is the other error?
So
what is likely to happen if you run this?
You need to increment I or else it'll run forever.
Yes, thank you, Zachary. All right. So because I is not incremented, because if I is not incremented and I is 0, right? By the way, on line 18, you declared a variable called I, but you didn't initialize it to 0. Now, if you're coming from Python or other languages, most common error. So Julian and all these other people who are already Python-y, right? They got to watch out for these things. Because in other languages, you get these things initialized. But here, I could be some junk value. Yeah, it could start off at, already 1 million. And then it won't go through the loop at all. So you got to make sure that in C++, all of these things are initialized. Again, even though you have to, it forces you to do that, that is actually power in your hands. Because rather than saying, oh, it's forcing me to do that, you should look at it as saying, hey, C++ gives me a chance to do that. Rather than in other languages, I don't even get a chance to do that, right? So you should look at it as an opportunity rather than something that is forced upon you, right? So is this okay? Now that while loop is fixed. Now this is the reason why sometimes people say, right, this while loop, why is it prone to error? Because it is scattered all over the place. Now I'll explain what it means, scattered all over the place, okay? So the incrementing happens here on line 27. Yeah? I is declared in line 18, up there. And the conditional is on line 25. So in 3 different places. And who knows what could have happened to I after you initialized it up there and then you use it here. All of the, so are these things bothering you, right? It is important that these things bother you, okay? Because that is how I think you get to be a better programmer, is just to look at things that are bad programming and be bothered by them. So you look at it and say, well, that looks like a bedsheet with crinkles on it. I'm going to iron it. All right. That is a feeling you should get when you look at, messily written programs or inefficiently coded ones. So that is why the for loop was invented. Okay. The for loop was invented so that programmers don't make as many errors by having things scattered all over the place. You have the initialization, the condition, and the incrementation, all of that in one place. So who would like to turn this whole thing, that while loop with everything else, into a for loop? Okay. Now that we know how it works and you've seen the while loop also, you want to turn that into a for loop. Okay. So how about someone maybe other than Raj, okay, who's going to call out the code to do the same thing with a for loop, okay, instead of the while loop. Not Rebecca, because you know, she's also had a chance, right? Yeah, right. So someone who is still unsure about this, you know, and also I know who was progressed to what stage in questing and so on and so forth. So I know that, you know, if I know whether you know these concepts or not. So if you already know it, you're not going to get a chance to do it. Okay. So someone who's still feeling unsure about arrays, do it in for loops. Hey, Raj, are you doing it yourself?
Oh, I just did it, yeah.
Okay, because you wanted to do it. All right, okay. All right. So but you know, that's fine. I was all right, random insert push front random. Okay, all right, great. Now now that it's been done in a for loop, let's get rid of the curly brace because there's only one statement. Right? And also get rid of that. Yeah, he's already gotten rid of the I assignment, you know, the declaration up there, right? You can get rid of the blank line on 18 also. Yeah. Blank line on 18. Now, is everybody okay with the for loop and how it works with in this context? Yes or no? Great. All right. Okay. Great. So line 26, enter again, and say clock T. Yeah, backspace. You know, unindent. Yeah. Clock T. And say now equals clock. No, open close. Okay, enter. Now we know the difference is now minus then, because you know it was 4 o'clock then, now it's 5 o'clock, so 5 minus 4 is 1 hour. Yeah. So on the difference, elapsed time. So you can now say clock T underscore T space elapsed underscore time. Hey, Chris, can you look up to see if the way we're calculating time is correct? Because I think there's something called clock type or number of ticks per second or something like that. You got to divide by that to convert the clock T thing into seconds, right? Right. Elapsed time equals now minus TS, right? You actually call TS then, right? That now minus then. All right. Yeah. In fact, you know, you can even call it after and before, but that's okay. All right. Now, on the next line, you want to say, see out, operation took, within quotes, you want to say operation took. And then elapsed time, and then no, clock ticks, not seconds. We don't know if it's seconds or not. We can find out endl after that, right? Endl. Right. So we're going to run this, and when we run it, it'll tell us how many clock ticks it took, and then based on the number of clock ticks, we have to calculate. What is it saying?
Saying push front.
Oh. Vector has no push front. Isn't push front a vector operation? Google for vector push front. Wow. What have I been using so far? No, click that.
Maybe. Would that work?
No, I've used push front for sure. I'm pretty sure. Oh, maybe vector does not support. No, click one of those. We want to see what the detail is. Yeah, well, yeah. Why did it says it's probably inefficient, that's why it doesn't exist. What do people use to push in front of a vector? What do people use? Maybe I'm just confusing JavaScript and other languages which allow push front. Yeah, see, that's a bummer. Because now
push front is for a list. Push front is for a list.
Oh, it's only for a list. Okay, so see, so I went through such a long spiel saying never use push front on a vector. It's the C++ engineers went one step further and say, why tell them not to use it? Will not give them the opportunity to use it at all. So they never even created one. Push front is only available for a list. Gee, I was trying to see if we could put that there. Oh yeah. All right, no. We will implement a push front ourselves. Okay, so I think maybe that makes sense, right? So maybe we implement a push front.
Which line?
Hmm?
Which line?
No,
do you
I'm
have?
thinking. Well, I'm thinking whether we should do. It actually did say. What did it say? Oh, push back. 46636. Right? No, but that doesn't tell us anything, because it says, well, I took numbers. I'm going to stuff them all in the vector one after another at all constant time. We don't learn anything from it. But if you push them all and then also had to do that operation, shifting elements, then for the first one you got to shift one element. The second you got to shift 2 elements, 3 elements, and so on. So after the millionth push front, you would have pushed how many elements? 1 plus 2 plus 3 plus so on, all the way up to 1,000,000. Yes? Because first time you're going to push 1 element. The second time you're going to push 2 elements. The third time you're going to push 3 elements. So if you want to push n times, each time you would have pushed that many elements. Yes? The total number of pushes you've made is 1 plus 2 plus 3 plus so on up to n. Yes or no? Yes? Okay. So what is 1 plus 2 plus 3 and so on up to n? And those of you who are doing algebra and math, you should know this, right? What is the sum of the first n natural numbers? It's n times n plus 1 over 2, right? n squared plus n over 2. That is the sum of the first n natural numbers, right? This is really interesting and nice proof of it too, that we won't go into. It's very simple too. Okay? So it's n, but because it's n times n plus 1 over 2, there's an n squared term in there. That says that, over time, the time taken by this operation increases the square of the number of items in it you're trying to do. So if you're trying to put, 100 items, the time taken is proportional to 10,000. You're trying to push 10 items, the time taken is proportional to 100. It's the square of the number of items. So that's why that is a slow operation. If you actually go to Desmos, for example, right? Open another tab, and go to Desmos graphing calculator. Another tab. Desmos graphing calculator. I click the first one, right? So type x squared, or y equals x squared. Yeah, x squared. Yeah, so that's a parabola. Now let's say you will have a line on the next line. Enter. You say y equals x. Right? So that's a line. A line, you can see already a parabola. If a program behaves like a parabola, the x-axis is the number of elements you have to process. Now, please stay with me here, okay? Even though it's not directly relevant to CS2A, it is important from the point of view of engineering programs that you are doing in CS2A, increasingly important in CS2B and C, right? The x-axis is the number of items you have to process. And the y-axis is the amount of time taken by the program to complete processing all those elements. In other words, if I only had to process 2 elements, right? The linear algorithm, the blue line, will probably take 1 second, right? Assuming it's 1, because the blue line intersects the 2, right? At 1. Oh, it's 2 seconds, right? So if I'm a 4, that's also 4 seconds. So it increases. The n items, it'll take n seconds to process. That's what the blue line indicates. Whereas the algorithm that is quadratic says, for 0 items, it'll take 0 seconds. But for 2 items, it is going to take 4 seconds. And you can vary, and if you zoom out, further back, you can pinch, right? You see how quickly it grows, right? So when you come to like 50 elements, already the quadratic algorithm is so slow compared to the linear algorithm. You see where that the vertical line 50 intersects with the red parabola is so high. That much time it's going to take to converge to a solution on 50 items. So you see the quadratic is much, much worse than linear. However, the important thing that many people overlook is that if you zoom in again all the way, pinch, you see that part up to, the part where the red line is actually below the blue line. That means there is some small subset of the data where the quadratic algorithm actually works better than the linear algorithm. The quadratic algorithm is faster, takes less time than the linear algorithm. Does it mean, but it'll come back to you later on when we talk about this in more detail. You'll actually see this in action, but this will come back to you, right? This will come back to you. So even forget it if it doesn't make much sense right now. Okay, so let's go back to the original tab. So we have Chris, did you find out how to convert clock ticks to seconds?
I'm still looking for it. Hold on.
You open a tab, we can find out together, right? Open another tab and say convert clock, C++ convert clock ticks to seconds. Yeah, click the first one. No, not that, not that. You know, there's some much nicer way to do this. Further down, maybe. Converting clock ticks to actual time. Yeah, click that. Further down. No, go back one more time. Let's try one more thing. Otherwise, I'll try something that I think I remember. No, clock ticks. Yeah, standard chrono system clock. Right, click that. Standard chrono system. Oh, clock function in C. Right, geeks for geeks. Click the next one. Clock function in C. Right, further down. All right, there you go. Right. So what we want to do is divide the difference by clocks per second. Divide the difference by clocks per second, and it's all got to be done in float, right? So cast it to float, cast elapsed time to float. In fact, you can say instead of clock t, you can say So you can say seconds. Size t and size t seconds equals and then within parentheses you're going to say float, right? And then elapsed time divided by clocks per second. Is that what it is? Clocks per second? Uppercase, I think.
Oh, here, I see.
Why isn't it auto-completing? That doesn't bode well.
Maybe
you got
headers are. They have math.h, time.h, and
no, those are not necessary for us. That's okay. It is in time. We got time.h. So no, let's go back and compile it. It's better to actually see what the error is. No, I think you got a syntax error. You got to. You don't have a. You don't need a parentheses after.
Oh.
Yeah. No, something is wrong here.
Well, no.
Oh, yeah, operation to not clock ticks. Yeah, you need to have seconds. Oh, it took 0 seconds. Because you're doing pushback, which is really fast. Can you just do a sleep? Can you do a sleep after the clock just to make sure that it's actually working? Do a sleep 1 second. So you should get at least one. You should, just do a sleep 1 second after clock. Yeah. And you need unistd.h at the top, and then you got an L instead of a semicolon too. Yeah. And then you got an L instead of a semicolon.
Here.
Oh, it's no, I thought it was a Y. I see. You're good there. Right. So run it. We should see at least 1 second there. Something is funny here. Why is it still saying 0 seconds? Sleep for 2 seconds. Something is wrong. Maybe it's not clocks per second, it's clock ticks per second. Maybe Chris would have found out. So we got to convert the elapsed time to number of seconds. Maybe it is not clock per second. I got to look in the quest code maybe, because I did that in the quest code. Unless someone is able to Google this and find out, right? I don't want to waste time figuring out, unless you want me to, figuring out if this is actually useful to you, right? If it is useful to you, raise your hand. If it is useful to you, just Googling to find out how to convert the clocks from whatever that number is into seconds, we can do it. But it's a straightforward application of something you're going to look up here, right? So I want to clocks per second. I think it's clock ticks per second. Or in the worst case, I can actually look at my code and find out what I did. Elapsed time divided by clocks per second. That looks. Is there a clock ticks per second? Yeah, try that. Try that. No, so there's no clock ticks per second. Maybe it's just ticks per second. Just Google for this. Yeah, we got to get really good at Googling lots and lots of things really quickly and finding out whether it is right or not. Because, you know, a huge part of being a programmer is basically finding out how to Google things quickly. You search the internet because everything out there, there's a solution, right? So what we want to do is convert the clock. Now, while he's doing this, someone should think up what the next concept we're going to talk about is, right? So it's something that your number of ticks per second, right? There, yeah. We want to say number of ticks per second. How do you know what the number of ticks per second is? Further down. Further down. How do you find the ticks per second? It's just, oh, gee.
Didn't really give you an answer.
You know, then go to another page. Don't waste time on this, especially since it's loaded with ads and all.
There's
how
a
many
C++
ticks? There you go.
documentation.
Sorry?
There's a C++ documentation for it. I sent the link in the chat.
All right. But you know, click the first one, Stack Overflow, before you click on the one that Chris sent. Just click that one. Maybe that is the answer. Further down. That's it. No answers. All right. So let's click on the documentation that Chris shared. He is using clocks per second. So that's what we did.
Maybe it's just a
clock minus t. No, that's not necessary. And it's not, it has to be clocks per second. That's exactly what we're doing, isn't it?
Before. Yeah, that's what we had.
That's what we had before. And why didn't it work? Elapsed, unless it may not have worked if elapsed time was 0, but we made sure elapsed time is not 0 by sleeping for 10 seconds or 2 seconds, right? So
Yeah.
elapsed time cannot be 0. And then you sleep for 2. Print the 2 clock values. Just print the 2 clock values. Print then and now. Print then and now. Print the 2 values. Print then and now. So it's like and also clocks per second. You can leave that line there. We want it eventually, right? So yeah, put it there. And then before the line, or there, yeah, all right. So you can say then equals and then yeah, all right. You need to tag it. Always good practice to tag it. Yeah. All right. And then left shift and then endl. And then also what was the other thing? Raj, I forgot.
Then now and then.
No. Yeah. Now. All right. Now, and then we also want to say clocks per second. Clocks per second equals. Clocks per second equals. By the way, for others who are watching, this is what we're doing essentially is debugging right now. We're not coding. Most of the effort of a programmer is really in debugging, even their own code, right? So you write it and it's not working. You want to find out why it's not working. Now, I could do the professorial thing and say, all right, now the debugging is for you to do, right? The students will do the debugging. That's really not a nice thing to do. So we're doing the debugging together here. Yeah, and then clocks per second, uppercase clocks per second, endl. Right now, run it, endl, and then run it. We'll see those numbers. Why are the numbers all messed up? All right, so it's got to be something like 77,000. Oh, I see. And the clocks per second is a million. Oh, I see. It's a million ticks per second. And then we're only ending up with this. So it is actually 0. But why? But the sleep 1, this is sleep 2. Why is this? Sleep 2 didn't kick in? May turn that into a sleep 5. Turn that into a sleep 5. Something's funny here. Okay, so something's funny. I need to take a look at this later. Maybe I'll have to run it on my machine. Maybe it's something to do with their Docker, the container in which they're running this machine. Because then and now they're like totally out of whack. Because if you sleep for longer, it should be more. So how about this? Extra credit for anyone who will do research on what's going on here. Take this is I may not share this video, but take a look at this, or take a photo, a screenshot of this, and find out why the hell is this not working? This is supposed to, according to the documentation too. We're taking the clock, sampling the clock then, and sampling the clock now, dividing by the number of clicks, and it actually works in all my other code. So why is it not working here? Unless I'm doing something crazy. If I'm doing something crazy, that is absolutely fantastic, because I totally don't expect it, and so anything you say, hey, that is actually crazy, and it'll be a pleasant surprise for me. Say, all right, totally worth it. Even totally worth making the mistake. Really, really funny. because well, the first time when Peter, the squirrel, was here, I offered him some nuts and he actually bit my finger. And then I told my son about this and he said, oh my gosh, this is crazy because you could have gotten rabies and all. But you know, for me, I was thinking, wow, okay, well, if I had gotten rabies, the surprise from seeing that totally unlikely theory be true. The theory is that it's impossible for me to get rabies through that. The pleasure of seeing that unlikely theory become true is actually totally worth getting rabies from, right? So it doesn't matter. So like that. So I don't know how we got started talking about that, but why is it not working? I'm very interested. Okay, if I'm going to find out anyway, whether you guys find out or not, I'm going to find out, but I'm not going to post about it unless one of you does or asks me. Right? We have not been successful in finding out. Find out and let me know. I will absolutely do that. I'm going to find out. Right? So this is homework and extra credit for you. You got to find out why this clock thing is not working, meaning that you got to do a little bit of research into what the clock function is, right? What it returns, how you convert from clock return values to the seconds and all, right? And divide and so on and so forth. So in our case, the reason it didn't work the first time I thought was because we're dividing 79,000 by a million, that's less than 1. But even then, it's float. It should report a number. It was putting 0. Oh, wait a sec. Let me take a look one more time. Elapsed time now minus 10. Where's now? Now is right, and then is also clock. I can't see anything that could possibly be wrong here. Wow, is it the time of day? Can anybody see something that's wrong here? Ben, Chris, Jonah, Liam, those of you who are more experienced with the Linuxy kind of things, can anybody see something out of whack here? We're sampling the clock 2 times, taking the difference and dividing by the number of ticks per second, which is 1,000,000. That should give us the amount of time in microseconds. Right? Yes? And it's not happening. So we'll figure that out later. All right. So that is how you fill a vector. Anyway, that is exercise in filling a vector. Let's try and do something more interesting with the vector. Okay. Now, this unfortunately fizzled out because I was thinking we'll do push front and thereby actually calculate the time it takes and demonstrate firsthand in our own minds, you know, basically etch into our heads the fact that push front on a vector is really, really bad. Never do it because it is inefficient in terms of time. But then it fizzled out because I didn't think through this enough to find out that, you know, the engineers, the C++ engineers already thought about this and said, we're not even going to allow a push front. That's really what happened. Okay. I'm pretty sure if you go to Stack Overflow or any of these places and say, why is no, why does vector not have push front and list has push front? Okay. Great question. Again, extra credit. Talk about this in the forums and say, hey, why does vector not have push front? And without referring to Stack Overflow and all these things, make your own case. Say, hey, well, it is inefficient. Here's an example. And I ran some experiments. For all of this, you get points. Okay. I ran some experiments. I set up the small experiment, which is a loop, and I timed it, and I found out that, you know, if I had a push front, this is how bad it'll be. That is a very good experiment to run. Okay. So I will recognize all of those things. Absolutely. Right. Oh, it appears that you know, Zach is saying something. Yeah, Zach, go ahead. Yeah.
I tried to run it on my computer, so it's not on GDP, but like I put a sprint statement right before sleep and right after sleep, and they're pretty practically the same values. So
it printed the same values before and after the sleep?
Yep. To the order of like 2 or 3 microseconds.
And even though you slept for many seconds. All right. Okay. All right. So great. That is also an interesting piece of information, you know, that came out of the research. So Zach found something out. So those are all mysteries for you to explore, because this is a mystery to me, right? I've been programming for a long time. And it is a mystery to me, unless it's a careless oversight that I'm failing to see right now because of the time of the day, maybe. It seems to me like it is bulletproof and it's not working. So it is a great mystery to me. So I'm probably not going to let me sleep until I find out, but I'm not going to spoil it for you. One of you should find out and take the credit for discussing this. Is that okay with you as a great opportunity for research and exploration? Yes or no? Okay. Great.
Sounds
Okay,
good.
so that's great, thank you. And it shouldn't be that, oh, let's say, Ben posted already, I'm not going to do anything. No, even everybody should do the same thing, right? Everybody should post, saying, hey, I did some research and I found this, right? Maybe you even say, I found the same thing as Ong posted. Yeah, that's fine, right? Yeah, there's only one truth. Everybody has to find the same thing. You can't say I found a different one. So say, all right, and I can corroborate what Ong found, right? That is the right way to do it. That is how science works. Yes. Because someone out there in Timbuktu does a research, some scientific experiment and posts numbers, right? This is how much time this new planet discovery, takes to rotate on its axis. But lots of people around the world repeat the same experiment immediately. Why they all don't just hey, all right, that's the number. No, everybody does the experiment and find out, yes, I corroborate that person, right? That's right. Yeah. Akira Finlay's result was correct, right? Oh no, they don't say it's correct, right? Managed to reproduce the result of Kira or Vivian or Eric, right? So you get these corroborations. These are called corroborations in scientific literature. The more corroborations a theory receives, the more likely it is to be closer to the truth, right? Whereas if a theory receives lots of falsifications, falsification means you propose something and someone gives you a counterexample saying, hey, that can't be true. Here, because it's a clear case that is not true. It's called a falsification. That means it's a blow on the theory. And the theory is dead, pretty much dead after that. Unless you don't have anything else, then you hold on to it despite the flaw. Saying, all right, until we get something better, we're still going to hold on to it. That is how scientific revolutions happen, right? You have a theory and lots of flaws are discovered, right? And they all go on like Band-Aid, right? After a while, there's so much Band-Aid on a theory that people say, all right, well, it's time to throw the whole thing out and start a brand new theory from scratch, okay? All the major scientific revolutions in history have happened like that. So we always stick with something that is tentative and then abandon it when there's too much plaster on it. So that's why even, when the theory of relativity, so many corroborations around there. So millions of people have done experiments to say, hey, the relativity is true. But when Einstein was asked, he said what scientists would say. Yeah, well, millions of corroborations don't prove that as much as one person saying, I got a counterexample, right? A falsification. Right? That is far more powerful than millions and millions of people repeating your experiment and saying that is true, right? Because counterexample is hard to find. And that is why true scientists are always looking for counterexamples to their own theories. And that's what gives them a great deal of, pleasure to in many ways. To find out that is something that is so likely to have been right, but yet this proves that is wrong. Yeah. Right. Okay. All right. So how about now? What is the next concept that you guys would like to look at? And we'll take a look at that again. Again, like I said, it's going to be practice, right? Today, the next 3 days until we start talking about pointers in week 10 is what we'll do. Right. Hey, Brian, welcome to class. Caesar, how you guys are late? Okay, you guys are late. So absolutely feel free to join. And also, I mentioned this before. There's a good chance I'll just stop publishing these videos later on because it's probably I'm told that it's against Foothill FERPA regulations or something like that, right? I want to keep these people happy too. So I might say, well, we won't do YouTube lectures, which means it's going to be important to come to class. You can't watch the video from now on. It may not be on YouTube. So who wants to do, what other concepts would you like to look at? Does anyone want to take a crack at creating a class with methods? We can do that if you want. Vectors, is there anything else with vectors you'd like to do? How about you create a vector? How about this? You create a vector and find the minimum element in it. Can you do that? How about this? This is good practice for you. And it's a vector of someone else other than Raj, okay? It's going to be a vector problem again. I'm not going to talk through this. Make a vector, just like Raj did. We're not going to time anything, right? Forget about that, wasted a lot of time. I wish we hadn't gone down that rabbit hole, okay? You make a vector. You're going to stuff it with 1,000,000 integers, just like Raj did, okay? And then you're going to find the minimum of those integers in another loop, okay? So you're going to find the minimum. So find the minimum and then find the stuff the vector. So there's two things you got to do in a loop. So who would like to do that? Ideally, someone who's still not 100% comfortable with vectors. Who's still not 100% comfortable with vectors? If everybody's comfortable with vectors, we'll move on now to start looking at classes, right? The next thing to do is create a class and methods in that class. And we'll pick a, we'll create a dumb class, a really simple class, because it's just practice. Let's create a course class and say, name of the course and the grade you got, two fields in it. That's all. Okay. With getters and setters, with the traditional stuff, this is what a class does, and so on and so forth. So actually, yesterday when I was walking, I was thinking, well, maybe we should come up with an interesting project to do today, like we've done in the past. But then along the way, I realized that I should probably focus more on the stuff that we've already done. And then I saw Vivian's message today. I kind of reinforced it, saying that, all right, let's not move forward and no new projects until you're completely comfortable with all that we have today, right? So what we want to do now is someone should take the screen, someone who's not comfortable with vectors. Don't say that, don't be like, I don't want to take the screen even though I'm not comfortable with vectors, because I don't want to take the screen to do something that I'm not comfortable with. That is the exact opposite. You should actually try and take the screen and do something where, especially if you're not comfortable with vectors, because if you're doing something on screen and people are looking at you, your classmates and everybody, you're going to be 100% focused on this, right? It is not like you're reading through a book and then there's, where your classmates are playing Fortnite, your roommates are playing Fortnite, and you're reading a book, and only 50% of what you read will, sink into your head. But here, everybody's watching you. And so this is the best use you can put your time to, and say, well, you know what, I'm going to focus 100% now, whether I like it or not. I'm being forced to focus 100%. So whatever I do now is going to stick to my mind. So this is a great opportunity. I shouldn't really be convincing you all to take the screen all the time, okay? So you should just take it, and then you just jump. In some quarters, people just jump over each other and say, hey, I want to code, I want to code, I want to code, right? So you should all be like that. Maybe it's time of day too. It's possible. Yeah. Maybe I'll switch to morning classes again. Maybe it's the morning, right? People are more energetic to code in the morning rather than the evenings, maybe. I don't know. The programmers always work at night, so mostly, many times. All right, so go ahead. All right, who wants to do this? We want to create a vector. This is, again, it's a short task. We create a vector, fill it with the 1 million integers, and you want to find out the smallest number in it. Okay, we've got 7 minutes for end of class. So I think this is probably the last thing we'll do. And we'll do classes, objects, methods, and so on and so forth next class on Thursday. And then we still have one more class to review all of this material next week. So we'll do this today now. Right? How about someone who's called Zero? The one next to Liam. His name shows up as
Oh, that's
Zero.
me. I'm
on
just
my
on my
screen.
laptop. Sorry.
Oh, sorry. Who is this?
This is Liam. I'm just on 2 computers.
Oh, Liam. All right, you got another laptop. I see. Okay, good. Oh, that's your laptop, and this is your desktop. I see. Great. Liam, if you want to take the screen, right? So you did mention this, and you go
sure.
second. So why don't you take the screen, and then you want to create a vector
Just give me like
of 1 million integers. And you can just feel free to type. Okay, feel free to type. I think most people are comfortable with vectors. If you're not comfortable with the speed at which Liam is typing, you can just ask us to slow down, and we will slow down. So when you're ready, Liam, take the screen, and then create a main, and in the main you want a vector of integers, just like Raj did. And Raj, thank you so much for creating that program. Hopefully that program was within 1 page, so it probably sticks in your mind too, so you can try and remember what Raj did. But you probably know how to do this. Do a vector, fill the vector with 1 million integers. Don't worry about srand, okay? Fill the vector with 1 million integers, then another loop to find the minimum of those 1 million elements. Okay, simple algorithm, isn't it? Simple algorithm. So you have to find out and then print the value.
All right.
And you just go to online GDB. Make sure you open an incognito or private window so that you don't accidentally autocomplete your social security number and things like that.
I would. I'll just do it in this. This works.
Oh, is this a VS Code?
So to create the vector of 1 million, they should be. Should I just use like a for loop to create them like linearly?
Yes,
Or should I do it
totally. But let's yeah, but also let's make this a habit. And go to the first line. Just make this routine. First line hash include IOStream and all those things. Just get into the habit of doing that all the time for for most programs. Hash include IOStream, and then hash include vector because you're going to be using vectors, and then using namespace standard. Right. So what you described was probably the right thing to do. You want to create a vector, and then you want to push back 1 million integers, right? And use the same kind of for loop. I equals 0, I less than 1,000 times 1,000 I plus plus, push numbers, 1 million numbers, and then you want to comment somewhere. Can you hit command control plus a couple of times, Liam? I think your font is a bit for these glasses anyway.
Okay,
Or
does that work?
is it the brightness of my screen? Yeah, that's good. Thank you.
Okay.
I'm on
So,
maximum brightness now.
So how do you spell
Oh, it's a
integer?
night mode. Yeah.
Okay.
Integers. Yeah. Okay. Great. Yeah. Fantastic.
Should I use random values or?
No. You want to do a for loop. You want to do a for loop, and then inside the for loop, you're going to call rand to give you a random number
You can do that
each
inside the
time,
loop? Not
and
right
then
here?
you want to push back that number.
You can put the rand inside the for loop?
No. You got to do the you got to do for int I equals 0. No, you don't need srand. All right, do srand if you want. Right, time null. Yeah, all right. This also works, by the way. It'll do the typecasting and everything for you. Maybe it'll complain, but it's a warning for size T. That's good practice, by the way, what Liam just did. She did the for. Lots of people just put the curly braces and then fill it in. Liam's gone one step further and also put in the 2 semicolons so that right? You'll reduce chance of compile time errors. So that is also very good for as you're beginning coding.
Is that how you use the pushback? It doesn't seem right.
I think if you do the dot p and then dot p, it'll autocomplete and show you the options. This is VS Code, isn't it?
Yeah. Okay, and then in here I type just rand.
Open and close parentheses. Make a semicolon at the end. And you can also get rid of the braces because there's only one line.
Well, I like to leave it there.
You like to leave it there?
Actually,
Okay. Right.
This is the only line within this to create
That's
the.
it.
Okay.
That's it. Yeah. All right. Now put a blank line after the vector int integers on line 7. Go to the end of line 7 and hit enter. All right. Now let's go to line 13 and start a comment. Right.
Okay.
Right. So find the minimum element in integers. How would you find out? Right. Either Liam can type or one of you can also dictate the code. It's perfectly fine. Yeah.
Okay,
How would you find the
so
minimum in that element in that list?
what are they called? Like the iteration loop. So it like does it uses this. I forget how to do those, but it would be like.
Yeah.
Like
that's good. That's good because it'll be practice now.
I'll just call it.
Yeah. Great.
And then or I guess like for the. So could I put I outside of this?
Yeah, in fact, line 10, you can copy the whole line 10 and paste it here, right? Because it's the exact same loop you're going to use.
Oh, okay. Yeah. Does that look right?
No. All right. So I
No,
I
I'm
can
just
I
kind
can
of
help
going
you.
off. I'm just doing.
Yeah. No. Yeah, most of it is right. Just line 18. Line 18. You want to say lowest equals
Oh,
integers
wait.
of I.
Not-
Lowest equals
not
integers. I
equivalent,
think
yeah.
that's what you meant, right? Yeah.
Yeah.
Lowest equals integer square bracket I.
You have to switch them?
Yeah,
Oh,
get
yeah.
rid of the
Yeah, that
yeah.
makes sense. Yeah.
Yeah, there you go.
Kinda
And
right.
then lowest equals. Now, however, we need to make a few more tweaks here because this is bug fixes. When you declared lowest on line 15, and I'm saying this only because I don't think, someone else had jumped in to mention this before, right? No, lowest is not 0, right? Because, it could have,
Negative numbers?
yeah. No, lowest is the first number. We assume just like a theory, scientific theory, we have a contender, and then we assume that is the truth, and we look at lots of evidence. As soon as we find some evidence that doesn't agree with the truth, we revise our notion of the truth and say, all right, the truth is now different. Scientific theory, yes? Because you look at the evidence and an evidence doesn't match the theory, you got a band-aid there. All right, so you got to patch up the theory to account for something that it cannot explain. And you have lots and lots of these band-aids, the theory is no good and you throw it out the window. That is what we're going to do here. We'll assume our hypothesis is that lowest is the first element. Okay, and then we're going to look at the second element. That's our hypothesis. If our hypothesis was correct, the second element should be less than the lowest. It is. All right, move on to the third. Less than the lowest. It is. Yes, our hypothesis is correct. Yes. Oh, the seventh element is actually less than the lowest. So that is now the lowest. Change your hypothesis. Does the process look kind of intuitive and familiar, hopefully, to you? Yeah, just going through the loop each time, checking if you've got the lowest, which is better than the current lowest. If it's better than the current lowest, you just update your hypothesis and say, now I abandoned my old hypothesis. My new hypothesis is that this is now the new lowest. That's all you got to do. Yeah. You want to call S rank? What's going on? You got an error on S rank?
Yeah, I think I forgot this library right here.
Oh, I see. Time.h. Oh, is it std look? Oh, yes. For srand you need, but also I think you need to call time.h because you're calling time. So in hash include time.h. Okay, compile it. Ran it? Oh, it's run. Has it run?
Yeah, it gets 0, so that might not be right.
No, it is probably right. It is
Yeah,
probably right. And the reason, yes, can someone tell me why it's probably right?
Maybe because it's a negative number.
No. It is probably right because you were doing 1,000,000 of those numbers, and
Okay, yeah.
it's
That does
very
work.
likely that 0 isn't
Yeah,
there.
it works.
What did you do? Oh, 10.
I lowered it to 10 and it got a non-zero number, so I guess it works.
Yeah. So if you went to 1,000,000, you always get 0, I think, because the probability that it's not a 0. In fact, extra credit for anyone is a math statistical problem. Okay, what is the probability that you get a 0 when you try to find the minimum of 1,000,000 random numbers? Okay, interesting problem for you. It's interesting mathematically and statistically, and it's relevant to computer science. You're generating 1,000,000 numbers. What's the probability that none of them is 0? Yeah. And they're all independent, right? Independent observations, so it's easy for you to calculate because the probability that the first number is not a 0. Yeah. And then you got to raise that to the power of 1,000,000. Okay. All right. All right. So I think that is great. That is great. So Liam, you were quite comfortable with this, I think, and thank you so much for volunteering and taking the screen. Hopefully you can do more of these too in the following classes. And anyone else who's also feeling less than comfortable with any of these concepts, if you're feeling less than comfortable, just volunteer. This is the best option. I'm talking you through this. Your friends are here. Everybody's talking you through this, right? I don't think you get this opportunity in any of the other classes. I don't know. In computer science here, at photo. And maybe even I won't teach like this, if I'm supposed to be teaching by according to the traditional ways, because I think there is a preference in the department or the division that the traditional way of teaching is probably the thing that should be encouraged. So maybe questing, I'll remove it at some point. Well, no, we'll have something like questing where you submit and I will grade it personally and manually. But this thing, while it's there, is a great opportunity for you, and it would be a pity for you to just waste it. Okay. I think anyway, that's basically the two things that I wanted. It's 7:56 and I know that you guys have to go home, right? And thank you all so much for sticking around even past time. I'm happy to talk to you and answer questions if you do have more. Hey, Megan, your camera is it a color? It looks almost a grayscale image for me. This is a black and white photo. So yeah, there's no color at all. It's almost like grayscale for me in your camera. Maybe it's a special setting or something in Zoom?
No, I haven't turned anything on. It's probably just the lights.
Or maybe it's just the lights. Yeah, it's crazy because everybody else's screen has got different colors in the room, but yours is all almost like grayscale. All right. Anyway, thank you all so much for sticking around. If you have any questions, you should ask and discuss in the forums. If you have any doubts as to anything that we talked about in class that you don't understand, bring it up and we'll talk about that. Right. I actually thought of a couple of interesting games that we can implement, but we'll save it for until we're comfortable with all these concepts. Okay, we'll have time. Maybe in week 10 we'll try and do something. I in a previous class I think we did something like a Wheel of Fortune, especially since we have these animations going, and that would be fun. Because it'll be a ring, and then you have to calculate. Yeah. Actually, let's do it this way, right? You will be given, that's linked list. We will be given a long linked list, and you have to find out whether it's a really long linked list or it's a ring. Okay, the last node links to the first node. How do you find out? It's an interesting problem for you to noodle, right? So you can noodle and think about how you can do that. It's an efficient way to do that, rather than use a dictionary like in Python and remember everything that you got and go to a million nodes. So we'll do that in class, maybe, or maybe a Wheel of Fortune game. Lots of, if you guys come up with interesting ideas on what we can implement and test, let me know, right? And then we'll do all those things in class. Was this class useful? I don't know if we covered we didn't cover any new material today, obviously, but I don't want it to be a waste. I want at least some of you who had less comfort with some of these concepts to be more. Raj gave me a thumbs up, okay, because he coded, right? Raj coded, I think Liam coded. So I'd like to hear from those of you who didn't code. And in fact, if you have, here's something you can do. Why don't you go to this survey that I posted last week? It's in your announcements. It's called Reflections, and spend a few minutes filling out your reflection. Reflection is essentially looking back on the last 6 weeks of class and saying, reflection is you look at the past, essentially, isn't it? Because anytime you look in the mirror, you're looking at your past self. You're not looking at your current self. How many of you realize this? Right? Because the light takes a finite amount of time to travel from the mirror to your eyes. So what you're looking at is you a few nanoseconds before. Yes? So you're looking back in time when you look in a mirror. So that's a reflection. So you can get a better reflection by looking more back in time than just a few nanoseconds, which happens with a real mirror. How do you do that? You can look at your Reddit posts. Okay. So when you've come to week 6, you can look at the posts you've made in week 1, week 2, week 3, week 4, and say, hey, in week 1, I didn't know this. Week 2, I didn't know this. Week 3, I didn't know this. Now, what do I know? So you can compare. That's your true reflection, right? So actually, when my daughter went to elementary school, they had her perform reflections every week. They say, hey, can you reflect? No, actually, no. There's a mirror. They called it a mirror. They have, a certain number of weeks, and they had to perform a reflection to say, hey, did I learn anything new? That's why I actually liked Stacey's email. Right, our first VPI we've had in a very long time, I think, who's actually focusing on, I don't know, from the emails, on whether the students are actually learning and getting value out of these things, as opposed to, are we just pushing more students out the door, giving them pass marks and A grades so that more enrollment and more money coming in the door, right? That kind of attitude is not good for a community college, I think, right? But over the last, ever since Stacey took over, and the emails have been coming out full of ideas for how to measure if you guys are getting your money's worth, if you're learning stuff, right? If you're interested in these things, and that and this reflection idea appealed to me. Let's put it that way, okay? It appealed to me very strongly because that is the best way you can tell. I can't tell you, right? By now you should have learned all this stuff. Who am I, right? I don't know. You may have many different life circumstances. The learning rate may be different at different times a day or a year. So you take some time to think of the last 6 weeks and say, am I better off in terms of C++ knowledge than I started with when I came into this class? And is it worth, right? It's not that, I just learned this one trick. No, is it worth, am I better off 6 weeks worth of time, of my effort in learning this stuff? And if you can fill in a couple of sentences saying yes, no, or I wish we'd done this better, or I wish we'd done it in a different mode. All these things are helpful. We'll look at the results next class, okay? On Tuesday, I'll make a note. We'll look at the results of your survey responses and say, this is what, and these are things that we need to focus on or change the way we do it. How about that, okay? That way we'll also keep changing. And I think it'll be interesting for me too, because if I do the same thing every single quarter, every same mode of teaching, same every time, it gets boring after a while. But then if student suggestions keep coming in, I keep switching up a little bit here and there, and then every time, every year, every quarter, it'll be different. Next quarter, I'll probably do a slightly different way, maybe more in line with foothill policies, maybe more traditional. I don't know. We'll think about it. So I've been thinking about this. I don't know if this thing works, right, with questing and these Zoom lectures and these things. So, but if we go back to that way and find out, we'll get a better idea. But you can always send me email, okay? And by the way, I don't know if I'm going to put these videos online. Well, maybe I'll put the videos online, but at some point, I think I might stop doing that. But you can get to see the videos by petitioning the dean and copying me. And if the dean or someone, the administrative people say, okay, I can share the video. I can share the video with you and you can look at it, because I think there's guidelines of what can be shared, especially with all your pretty faces on the screen. I think there may be guidelines saying you can't share photos of images of student faces on public media. So I'll find out. But if that's the case, you can always petition and get a chance to look at the video on your own. The best thing to come to class and just watch it live. Is that enough? Is that okay? I know Raj was the only person who gave me a thumbs up. So how about everybody try to get those stars? Everybody, wait, I'm not getting any now. Nobody else is getting any. How come Ben, keep your thumbs up in the air for a while? How come nobody else is it only the organizer? Oh no, Zach got it. Oh, only the people with Macs. Only the people with Macs. So we can find out. So I can find out who's got Mac. Spencer, you got a Mac? Yeah, you got a Mac, right? Your dad works at Apple. Right? You're not getting this. You're not getting this. Maybe it's an old operating system, old version of the operating system. 2. What is 2? Ria. Oh, balloons. 2 was balloons. Yeah, I forgot. 2 was balloons. Yeah, cool.
There's also a heart.
Great. All right. Anyway, thank you. Please fill in the survey. Or else, I'll probably take 5 minutes at the beginning of next class for you to do the survey, and it's easier for you to do it now. Hopefully, you got the link. Otherwise, ask me, and I'll send it to you. Fill it in, and we'll go over the suggestions at the beginning of next class. I'll try and think up some new ideas too, right? Of what we can do. Today, I had this idea of this, demonstrating the badness of push front, but obviously it's been disallowed completely. So there's no chance for me to do that. Push front is not allowed for vectors for good reason. All right. So that's all I have. If you have any other questions, I'm happy to answer them. Otherwise, Ben is yawning already. So you got to go. And but you're home, Ben. You're not in the library. Okay. All right. Thank you all. Okay. Thank you all. And I'll see you on Thursday. I'll see you on Thursday. All of you should come to class on Thursday, and come with questions. Okay, come with questions like Vivian post questions on and say this is what we want to talk about. It's better if we decide on what we want to talk about before class so that we can come with a plan. And today, let's talk about something what you don't know, and then we create a problem, concoct something there, and it's not so exciting. Thank you. Good night.
Right.
Professor. So
Yeah, sure, Ria.
On the problem where we were trying to find the like time elapsed, is there a reason
Yeah.
put seconds as a size t?
No, oh, seconds. No, I think it was clock _t.
Oh, seconds should have been a clock?
Oh, seconds was size t, was it?
Yeah.
Oh my gosh, yeah. Why didn't you say this in class? That's why it was 0, because 0.79.
Oh, I typed it in chat, but I just didn't say it.
Yeah, right. That's why, chat is no good. You should basically have said that right now, right then, because, that was obviously the fault, right? I said, if there was something super silly wrong in this, and that was it. It's a size t, and obviously it is 0, and nobody pointed it out. It goes all the way back to, the first week data representation, size t and float and expressions, and nobody pointed it out. Okay. Well, you should post about it. Okay, post it in Reddit and saying, I found out, and this is the reason, and more of you should have found out. No, don't say that, but that is the reason. Yes, thank you so much for bringing that up.
Cool. Thank you
Right.
so much.
No worries, and best of luck for your AMC and all.
Thank you. I already did it, but yeah.
All right. Oh, you get the numbers immediately, right? The results immediately.
No, I get
I
them
forget,
tomorrow, but yeah.
a long time ago. Yeah, tomorrow. All right, but yeah. All right, good luck.
Bye.
See you later, Milton,
Tomorrow.
and you too, and Caesar.
Wednesday.
Hey, Milton, you here? Milton? Caesar? Okay, all right. So you got to get back to me.